operation. So compass sensor, it looks like this. All the sites are mentioned here. Normally, the north pole is a powerful pole where the needle is always show the north pole. But this magnetic force of the earth is so weak that people previously used to design compass by suspending thin magnetic strip. So in early days, they have just used a magnetic strip and they used to find the direction. In the compass present in smartphones, magnet is not used as a component because it causes interference in communication. So in smartphone phones, we have compass, and you cannot use magnet there since it will interact with the other components which are present in the mobile phone. So digital compass sensor is actually a magnetometer that can measure the Earth's magnetic field with the use of Hall effect, and by calculating the ultra low frequency signals coming from north or south direction, this sensor can calculate the orientation and direction. So heading sensors are the direction sensors are one and the same. So here magnetometers are used with the Hall effect principle. So we have seen Hall effect also in earlier classes. Working principle: the first compass used in 11th century was a simple structure with a bowl of water containing a magnetic needle floating on it. So here it is the first compass used with water in a bowl on which the needle is made float. Later, many improved and reliable versions were developed. Digital compass sensor that is used in smartphone is based on a magnetometer sensor. The resistance of magnetic sensor present in magnetometer changes in proportional to the magnetic field present in a particular direction. So the magnetometer measures the magnetic field strength and orientation. So with this, we can get orientation also. It is possible to estimate or get the orientation. Working principle: this information from magnetometer is stored in the CPU as digital data. This sensor always points towards the geometric north. So here it is also geometric north. It represents or it shows it turns towards north always. The compass found in electric devices is a solid state sensor. Solid state accelerometers are also used. Usually, two or three magnetic sensors are present on the device from which the microprocessor can read data and detects the orientation of the device. Magnetic compass sensor: there are two configurations of compass sensors available based on their working principle. They are the magnetic compass and gyro compass. So these are the two types are available. And magnetic compass contains a magnetic element to detect the magnetic field. This magnetic element aligns itself with the magnetic lines of Earth magnetic field. Magnetic compass points towards the magnetic pole of Earth, whereas gyro compass points towards the true pole of the Earth. Gyro compass consists of a rapidly spinning wheel. So that is the gyro compass. Gyroscope sensor is a device that can measure and maintain the orientation and angular velocity of an object. So here, this will measure and maintain the orientation and the angular velocity as well of any particular object. There are more advanced than accelerometers. So these are more advanced than accelerometers. They can measure the tilt and lateral orientation of the object, whereas accelerometer can measure only linear motion. So that is the advantage more features we have with the gyro sensor. Gyroscope sensors are also called as angular rate sensor or angular velocity sensors. So these are the other two names for gyroscope sensors. These sensors are installed in the applications where the orientation of the object is difficult to sense by humans. So here it is used employed where the humans struggle to find the orientation. and measured in degrees per second angular velocity, the change in the rotational angle of the object per unit time. So this is the angular velocity in this units. The angular velocity is measured and recorded. So this is the gyroscope sensor. It can have all three axes. So tilt, orientation, the yaw position can be determined. So in all three axes, it can be employed and used. Gyroscope sensor working principle. Besides sensing the angular velocity, gyroscope sensors can also measure the motion of the object. So it also measures the motion of the object. For most robust, accurate motion sensing in consumer electronics, gyroscope sensors are combined with accelerometer sensors. So as a combination with the accelerometer, also these are used. Depending on the direction, there are three types of angular rate measurements. Yeah, the horizontal rotation on a flat surface. When seen the object from above pitch, vertical pitch is the vertical rotation as seen in the object from front. Roll, roll is the horizontal rotation when seen the object from front. So yeah, pitch and roll. These are the three parameters. Even that can be measured using a gyroscope sensor in three mutual perpendicular directions. Gyroscope sensor working principle as we saw in last slide. The concept of Coriolis force is used in gyroscope sensors. In this sensor, to measure the angular rate, the rotation rate of the sensor is converted into electrical signal. So here also the output is in the form of electrical signal. Working principle of gyroscope sensor can be understood by observing the working of vibration gyroscope sensor. It is gyroscope sensor or vibration gyroscope sensor are both in similar in construction. Inclinometers. An inclinometer is a sensor used to measure magnitude of the inclination angle or deformation of any structure. The bent is either depicted in percentage or degree concerning gravity. So here, these inclinometers are used to measure angle inclination in terms of angle inclination of any object or even a structure, whatever it may be. Inclinometer sensors are used to measure the slope gradient during activities like tunneling, excavation, and dewatering. Such activities affect the ground that supports the structure. The inclinometer installation procedure depends on the application field. It can be installed vertically to monitor the cut slope or any movement in the shoring wall and embankment. So here it is also used for alignment of any construction work. To monitor the settlement of soil above this part of tunneling, inclinometers are installed horizontally. So even inclinometers can be used horizontal direction also. Inclinometer sensors are of different types. Each inclinometer system requires a combination of equipment and sensors to measure and collect data. So here this is the inclinometer application. So this is very similar in construction. See, this is the construction. This is the control cable from where you can hang it through wheels, upper wheel upper wheel assembly, and this is the upper wheel of lower wheel assembly. So here two wheels within which this can be made to hang or made to place. So here this is the inclination can be measured. So in terms of angle, so here this is L sine theta. If this is theta, opposite side by hypotenuse. With that we can get the theta value, and this is the actual alignment guiding casing. So this is the extravagated, and this is the distance between successive readings, right? So here you can with this L value, you can measure theta value. So this is the application, and this is the construction of inclinometer. So this is the readout unit. Even nowadays we are getting the output in digital format also. So this is the bore hole in which it is made to travel, and this travels, and any inclination, right, that can be observed. So this is the top view of the borehole. This is how you can apply inclinometers in practical applications. A digital inclinometer system is composed of following components: inclinometer probe, inclinometer cable reel. So here it is marked at every zero point 0.5 meter per 1 meter. So at every zero point 0.5 meter, it is there is a mark made. Android mobile readout unit, accessories, cable reel battery, battery charger, mobile battery, mobile charger. The digital inclinometer system is most commonly used one for manual inclinometer probes. The two MEMS sensors are mounted 90 degrees to each other biaxial. The probe ranges to plus or minus 30 degree from vertical. So this is the inclinometer with in digital form. The data is retrieved using a traversing application. Let us understand each of the components in detail. The inclinometer probes are built using two types of accelerometers. One is a servo accelerometer, the force balanced sensing element housed in an inclinometer probe detect the change in tilt from reference. The probe consists of a couple of biaxial servo accelerometers. So here this is the servo mechanism. It is like it can adjust for any errors. So it is possible to adjust by itself. So that is servo accelerometer. It is fitted with the two sets of spring pressured wheels to guide the probe along the longitudinal grooves of the inclinometer casing. So this is the construction of servo type. And another one is MEMS accelerometer. So MEMS is nothing but micro electromechanical systems. Such inclinometers are termed as MEMS inclinometers. This technology is being used to build a tilt sensor probe. Your tilt can be measured using this sensor probe. The MEMS consists of mechanical elements, sensors, actuators, and electronics on a common silicon substrate through microfabrication technology. So this is how using microfabrication technology it is made or fabricated. So acceleration causes deflection of the proof mass from its center position. There are 32 sets of radial fingers around the four sides of square proof mass. These fingers are placed between plates and are fixed to the substrate. Each finger and a pair of fixed plates makes up a differential capacitor. The deflection of the proof mass is determined by measuring the differential capacitance. So in terms of capacitance, we can measure the inclination. By this method, both dynamic acceleration, shock or absorption, vibration, the static acceleration, i.e. inclination or rotation, can be sensed. Signal conditioning is carried out with inclinometers so that a simple output signal is obtained. This output can be used in conjunction with the calibration sheet to easily calculate the amount of tilt that has occurred. So this is one simple case study. You can also build your own case study, and you can show in your regular classes. Here we stop with heading sensors in and also we are completing the unit number 4 here. So far, any doubts you can ask me in your regular class during Wednesdays and Thursdays. Thank you, students. Thank you.